Hello, welcome to the session Alcohols, Phenols and Ethers. Of course, all organic chapters are very long chapters. So, in the previous class, I hope I completed what are alcohols, classification, their properties, etc. So, on the basis of that, some questions were given to you. Here is the question: RCOOH plus HO18O dash with concentrated sulfuric acid gives ester plus H2O. In this reaction, ester is radioactive, water is radioactive, both are radioactive, cannot say definitely. So, remember, this is the reaction in which the bond between H and O of alcohol is broken. So, it will be RCOOH plus R dash OH. So, H2O will be removed like this, which has been already written here. Therefore, oxygen 18, the radioactive oxygen is present in the ester, hence ester is radioactive. The bond between O and H of alcohol is broken. Therefore, H of alcohol and OH of acid will form H2O. Therefore, ester is radioactive. Okay. We have already completed preparation and properties of alcohols. Today we are going to take up some numerical problems with respect to alcohols, then introduction to phenols, what are phenols, classification, differences between alcohols and phenol. This is what I want to complete, but it may or may not be possible. How do you distinguish between methanol and ethanol? Methanol and ethanol. When I say distinguish, it is distinguishing reaction. Distinguishing reaction. The tests are like this: heat it with iodine and sodium hydroxide. Heat with iodine and sodium hydroxide, no reaction, whereas here you get yellow crystalline solid. Crystalline solid, and this solid is iodoform. It's iodoform. That is methanol and ethanol. The next one, see, when we distinguish, at least you should write one positive test for methanol, one for ethanol. So, I have written one for ethanol. Now, heat with salicylic acid. Heat with salicylic acid. Salicylic acid. Yes, I will come to that. Good evening, happy Diwali, Devi Priya, Radhika. Yes, iodoform, Radhika, you are right, iodoform is obtained. Heat with salicylic acid along with concentrated sulfuric acid, and then pour this to dilute sodium carbonate solution. Shubha Sanjay, Vishwas Gowda, thank you. You pour it into sodium carbonate solution, you will have the smell of oil of winter green, oil of winter green, due to the formation of methyl salicylate, methyl salicylate, no oil of winter green. See, what do you mean by this oil of winter green, methyl salicylate? If you smell iodex or amritanjan, today when you go home, you please see the bottle of iodoform, bottle of either amritanjan or Vicks, you will see the name methyl salicylate. That is how you can distinguish methanol from ethanol. Okay, what is the product obtained? Can anybody tell me what is the product obtained when ethanol is heated with Al2O3 at 523 Kelvin? Quick, can you tell me quickly what happens? Yes, anybody? Ethanol, Al2O3, 523 Kelvin. What is A? It will give A. What is A? Okay, so it is ethoxyethane. Ethoxyethane. If the temperature is still higher, you get ethene. It is ethoxyethane. Okay. How is ethanol manufactured in countries where sugarcane is not grown? See, in our country, you know that sugar is hydrolyzed to glucose and fructose by invertase, then glucose undergoes fermentation by zymase to form ethanol. This is the classical method or traditional method. So, sugar, this is how we get, because we grow lot of sugarcane, Brazil, Indonesia, so New Zealand, West Indies, they grow sugarcane, therefore they manufacture ethanol by this. But in the countries where sugarcane is not grown, petroleum is available in plenty. How is ethanol manufactured? An important method from petroleum industry. Ethanol is obtained from petrochemicals. Yes, anybody? Vishwas Gowda. Heli. How do you get in the countries where petroleum is available in plenty? Okay. CH2, double bond CH2, ethene is a petrochemical, and this is the raw material for the manufacture of that. This is hydrated. In presence of concentrated sulfuric acid, it forms CH3, CH2OH. So, petroleum is available, it is a petrochemical, therefore, hydration of that will give you that. Okay. Next one, write all the products of oxidation of ethane 1,2-diol. Ethane 1,2-diol. Write all the products of oxidation of ethane 1,2-diol. Can you tell me the products, different products are obtained. If you can tell me the product. Yes, Saurav, Radhika. Yes, anybody? ethane 1,2-dial. Okay, that's one of the products, Radhika. Slow oxidation will give you this CH2OH CHO. Primary alcohol on oxidation will give glycolic aldehyde. This glycolic aldehyde on further oxidation will give what you said, CHO, CHO, glyoxal or ethane 1,2-dial, or this on oxidation. You know that CHO on oxidation will give carboxylic acid. You get glycolic acid. Glycolic acid. Glycolic acid. This on further oxidation can give CHO, COOH, glyoxolic acid, glyoxolic acid, glyoxolic acid. Now, both of them on further oxidation will give COOH, COOH, oxalic acid. So, stepwise oxidation will give oxalic acid as the final product. I repeat the names: glycolic aldehyde, glycolic acid, glyoxal, glyoxolic acid, oxalic acid. Whereas the second product with HiO4, the reaction stops at this point, glyoxal. Radhika, what you said, ethane 1,2-dial. The reaction stops there. This particular HiO4 oxidation, yes, final is oxalic acid. This particular HiO4 oxidation is used in establishing the rings structure of carbohydrates. Ring structure of carbohydrates. HiO4 oxidation, periodic oxidation, is used for establishing the size of the ring in carbohydrates. Okay. This is another important reaction. KHSO4, dehydrogenation and dehydration both will take place, forming CH2 double bond CH, CHO. This is called acrolein. This is a test for glycerol. This is a test for glycerol, oils and fats. Oils and fats. This acrolein has got very foul smell. Very foul smell. So, glycerol, oils, fats, if you heat it with KHSO4, undergo both dehydration and dehydrogenation, giving acrolein. This is a test for glycerol, oils and then fats. Okay. So, this is the reaction of KHSO4 with glycerol, fats and then oils. Okay. Then question number, so this will have very foul smell. Okay. Right. The next one, sir, oxirane will not be formed as a product. No. From glycerol, from ethane 1,2-dial, oxirane will not be formed. No oxidation. Okay. Glycerol with KMnO4 will give A, B, C. A is oxalic acid, it is a simple reaction. A is oxalic acid, B is carbon dioxide and C is water. Simple reaction of glycerol. Okay. Yes. A, B and C. A is oxalic acid, B is carbon dioxide and C is water. Okay, the next question. This is, I will give you some time. Can you answer this question number 7? Anybody wants to answer question number 7? ABC is over. The next question. Can you tell me, at least can you tell me what is C? Glycerol plus oxalic acid crystals are heated to 503 Kelvin. Can you give me what is C? Yes? Anybody? Formic acid plus water. Excellent. Excellent. Radhika? Excellent. This will give glyceryl oxalate. This will lose a molecule of carbon dioxide to form glyceryl formate. Glyceryl formate. This glyceryl formate undergoes hydrolysis, giving formic acid. Excellent, Radhika, very good. But you don't get water. Along with C, formic acid, you get glycerol back, plus glycerol. So this is A, this is B and this is C. Glycerol is got back. Glyceryl oxalate on hydrolysis will give glyceryl formate, which on hydrolysis will give formic acid and then glycerol. Very good. This is a laboratory method for the preparation of formic acid or methanoic acid. Okay. So A is glyceryl oxalate, B is glyceryl formate, C is formic acid, and you get back glycerol. Okay. The last question for today, that's enough because it's already time up. I would like to go to phenols. Which of the following undergoes dehydration most easily? Can you give me the answer for this? Which of the following undergoes dehydration most easily? I think all of you probably know the answer. If you can give me the answer, I will proceed further. Yes, anybody? B, Mansi, B is the answer. You please think over which one is the answer. I will Mohan Potluri, you say Yash Pratap Singh, B, Radhika says D. Okay. The answer must be D. The answer must be D. Okay, that's enough for today. I will go to the day's portion, Introduction to Phenols. Introduction to Phenols. Right. Phenols, as your syllabus says, is an aromatic compound in which The OH group is connected to the benzene ring directly or to sp2 hybridized carbon. This is sp2 hybridized carbon. So, phenol is an aromatic compound in which the OH group is connected to sp2 hybridized carbon atom of the benzene ring. Just like alcohols, phenols are also classified into monohydric phenols, those which contain one OH group. Dihydric phenols which contain two OH groups, and then trihydric phenols which contain three OH groups. I do not want to go into the details because you know it better than me. One OH group is monohydric phenol, 2 dihydric phenol, 3 trihydric phenol. So, any compound which contains one OH group is monohydric phenol. For example, salicylic acid, it is a phenolic acid. See, OH and then COOH. This is salicylic acid. Salicylic acid is a phenolic acid. Monohydric, it belongs to the family of monohydric phenols, whereas resorcinol, catechol, quinol, etc. belong to the family of dihydric alcohols. For example, OH and then OH. Catechol is a dihydric phenol. So, salicylic acid is monohydric, catechol is dihydric phenol. Trihydric phenol is pyrogalol, benzene ring with OH, OH and then OH, pyrogalol. This is trihydric phenol. Okay, that is more than sufficient for the classification of phenols. Now, we shall see in what way phenols are different from alcohols. This is trihydric phenol, that is one which contains 3 OH groups, and all the 3 OH groups are connected to sp2 hybridized carbon atom. Sir, acetyl salicylic acid is phenol group. Acetyl salicylic acid has no phenol because the OH group has been converted into OCOCH3. OCOCH3. Therefore, it is not a phenol, it is an ester. Acetyl salicylic acid is an ester plus COOH group, carboxylic group. So, it becomes OCOCH3. Here is salicylic acid, I will write it, I will change OCOCH3, OCOCH3. It becomes acetyl salicylic acid or aspirin, an ester and a carboxylic acid, both. It is both an ester and a carboxylic acid. Okay, Raghu? Fine. Next, coming to the differences between alcohols and phenols, because salicylic acid was there, ask Rathar. Yes, correct, you are right, Raghu, you are right. Salicylic acid has got the properties of phenol and carboxylic acid, whereas acetyl salicylic acid loses its phenolic property because OH becomes OCOCH3. Excellent, fine. Okay, right. Now, in what way phenols are different from alcohols? Phenols are more acidic than alcohols because of the delocalization of pi electrons, resonance. Phenol exhibits resonance, which is absent in the case of alcohols. Phenol is one in which the lone pair of electrons on oxygen will be in conjugation with the pi bond, pi electrons. Therefore, there will be delocalization of pi electrons. So, delocalization, OH group is an electron pushing group. It has got plus M effect. OH has got plus M effect. Mesomeric effect, it pushes the electrons into the benzene ring, activates the benzene ring. It activates the benzene ring. Therefore, it will have the following resonance structures. Sorry. It will have the following resonance structures which you already know. So, OH, it becomes O plus H, and then this will move over here. So, minus, and this will continue, which you already know. The ortho and para positions will have negative charge. Yes, Radhika, yes, because of resonance, there will be delocalization of pi electrons. This gives rise to ortho form, in which the ortho position will have excess of electron density. Similarly, you will have para position with excess of electron density. And then again at ortho position you will have excess of electron density. Therefore, OH group is ortho para directing group. Ortho para directing group. So, this gives rise to, back to this, delocalization of pi electrons. This gives rise to another Kekule structure, OH. Yes, anybody? See, all these will give rise to the resonance hybrid. Delocalization of pi electron will give rise to resonance hybrid. The question is, Radhika, Raghu, Vishwas Gowda, all of you, one question. There are 5 resonating structures for benzene, for phenol, 4 plus 1. 5 resonating structures are there for phenol. Which one or which forms 1, 2, 3, 4, 5 contribute to the maximum extent to the resonance hybrid, and why? Anybody? Raghu, Radhika, Vishwas Gowda, Mansi, anybody who can answer this question? 1, 2, 3, 4, 5 resonating structures are there for phenol. Which of them will contribute to the maximum extent? Raghu says number 5. Anybody else? 1 and 5, Patluri, 1 and 5. Okay, accept your Mohan Mohana Patluri. I accept your answer. Can you tell me why? I will come to the Radhika. Mohan Patluri. Mohana. 1 and 5. Why? Can you give me the reason for it? Your answer is fine. Excellent. Correct. 100% correct. 1 and 5 contribute to an extent of 70% to the resonance hybrid, because they have low energy. 1 and 5 have got low energy. 1 and 5 lower energy. 2, 3 and 4 because of polarity. Because of polarity, they possess higher energy. Lower energy state will contribute to the maximum extent to this. So, remember, the resonance structures having ions or charge separation, their contribution is minimum to it, because 2nd and 4 involve separation of charges. Yes, you are right. Separation of charges and polarity, their contribution is less to that. Okay, the next one. When phenol is dissolved in water, it is an acid, proton donor, it becomes C6H5O minus and H3O plus. C6H5O minus, phenoxide ion and hydronium ion. This clearly shows that phenol is acidic in nature. It donates its proton. Water is a base. Phenol is acidic, water is basic. For phenol gives out proton and water accepts proton. Therefore, the equilibrium constant K for this is active mass of C6H5O minus into active mass of H3O plus divided by active mass of C6H5OH into active mass of H2O. You know that active mass of H2O is constant. I will call it K dash. Therefore, K into K dash is equal to active mass of C6H5O minus into active mass of H3O plus divided by active mass of C6H5OH. This is called Ka. Sir, phenol is weak acid, right? Certainly weak acid. Certainly. Very weak acid compared to any carboxylic acid, HCOOH. Phenol is weaker. CH3COOH, phenol is weaker. Even oxalic acid, compared to oxalic acid, phenol is weaker acid, very weak acid, weaker than carbonic acid. So, Ka value, if Ka value is higher and higher, acid strength is higher and higher. But you know that the acidity is measured in terms of pKa. pKa is equal to minus logarithm of Ka, minus logarithm of Ka. Yes, minus logarithm of Ka. If pKa is higher, acid is weaker. If the pKa is lower, the acid is stronger. Acid is stronger. So, pKa value and the strength of the acids and bases are inversely related, not inversely proportional, it is inversely related. pKa higher, acid is weaker, pKa lower, acid is stronger. weaker is the acid, pKa, yes. Now, what happens to the acidity of phenol if we introduce? So, if we introduce substituents, what happens to it? So, I will write this is phenol, this one is para-nitrophenol, this one is para-cresol. I have written 3 different compounds containing OH group, monohydric phenols, phenol, para-nitrophenol and para-cresol. This is phenol, this is para-nitrophenol and this is para-cresol. Now, phenol is acidic in nature. It is a very, very weak acid. Its pKa value is roughly about 10. Phenol pKa value, so I will write it, pKa value, it is about 10, whereas para-nitrophenol it is 7.2 and para-cresol is 10.15. Okay. So, substituents like NO2, Cl, F, CH3, C2H5, they affect the acid strength. Yes, nitrophenol, phenol, para-cresol, order of acidity, correct Radhika? So, the principle behind this is, if the substituent is an electron withdrawing group minus M effect or minus I effect, acid strength will increase. So, NO2 group, I will write it, NO2 group, F group, Cl group, etc. increase the acidity of phenol. They make phenol more acidic because these groups make phenoxide ion more stable due to resonance. So, nitrophenoxide ion is more stable, whereas, so these groups decrease pKa, value, therefore, the acid becomes stronger and stronger, whereas CH3 group has got, it is an electron pumping group, it has got positive inductive effect. This makes phenol a weaker acid because it is pumping the electrons towards OH group. Here electrons are moving away from OH group, here electrons are moving towards OH group. Therefore, plus I effect will increase the pKa value. So, groups like CH3, C2H5, then C3H7, etc. will increase the pKa value, hence the acidity of phenol decreases. If minus I effect group or minus M effect groups go on increasing, pKa value decreases, it becomes stronger and stronger acid. If plus I groups increase, it becomes weaker and weaker acid. Therefore, pKa value will increase. So, this is the acidity of phenols, NO2. Okay. Now, I would like to ask you a question. Probably you are in a position to answer this. So, I will ask you a question now. This is phenol this one is 2,4-dinitrophenol. This one is orthonitrophenol. Now, the question is, out of the three, they ionize to form phenoxide ion. The question is 1, 2 and 3, which phenoxide ion is more stable? Which phenoxide ion is more stable? Yes, anybody? Which? What is adduct? Adduct is one which adds on, addendum and adduct. Addendum is one which adds on, adduct is one which takes up the addition, that is called the adduct. Addendum and adduct, Diels-Alder reaction, we use those words adduct and addendum. Even addendum is used in Markovnikov's rule. Okay, Jitesh. So, anybody? Which phenoxide ion is more stable out of the three? Yes, quick, it is time up now. In the next class, I will take up preparation of phenol. Radhika, 2. 2 is the answer correct, because NO2 group is an electron withdrawing group. There are 2 NO2 groups which are electron withdrawing. Therefore, it is stronger acid. When compared to others, it is a stronger acid. Therefore, phenoxide ion is more stable. Okay, fine. Radhika, your answer is correct. Okay. The previous session contest question which is distributed more widely in a cell? Which is distributed more widely in a cell? DNA, RNA? Yes. Which is distributed more widely in a cell? DNA, RNA, chloroplasts and spherosomes. Spherosomes. Okay. The answer is B. Winner is Monsi. An atom session will be added to her account at the end of the day today. Yes. 3. Okay, fine. So, I will continue in the next class. So, here is a question contest. It is a contest time. Here is the question. Acid catalyzed hydration of ethene forms A. This is heated with alkaline chlorine to get B. This, when heated with an acid, undergoes hydrolysis to give C. Write equations. Yes. Write equations. Okay. So 1 minute time, in that you complete this question. What is C? Write equations for this. Okay. So we did some numerical problems, introduction to phenol and what are phenols, and then classification, differences between alcohols and phenols. Then I will take up properties. Thanks for joining. Get the passport, get access to class practice packs sent by your teacher with passport. Okay, fine. So I will continue. Yes, ethoxyethane. I will take up that question in the next one, Monsi. Okay, fine.